All right, good morning, everybody. Thank you for being here with us today. For those of you that do know us, good to see you again. For those of you that don't know us, we're the Virginia Tech Advanced Auto Capstone team employed to investigate company data and ultimately predict new store performance. Without further delay, my name is Jared Brossman. I graduated from Virginia Tech with a degree in economics and data science, and I'll be working as a technology analyst later this August.
My name is Bobby Beal. I graduated from Virginia Tech with a degree in Business Information Technology and Business Management, and I'm looking to work in data analytics after graduation.
My name is Kim Wonderful Paisart. I graduated from Virginia Tech with aerospace engineering degree, and I'm going to work as a business analyst in August this year.
My name is Pratik Battardini. I also went to Virginia Tech, and I majored in Business Information Technology, and I hope to work as a tech consultant this fall.
And my name is Graham Fike. I also went to Virginia Tech and got a Business Information Technology undergraduate degree. And I hope to be working in consulting this coming fall. So before we get started, we just want to say a couple thank yous, especially to our faculty advisor, Jonathan Everett, who's been very helpful throughout this project, especially during the financial pieces. And also, of course, thank you to our sponsor, Advanced Auto, especially Brad and Roger, who have been instrumental in this project. So without further ado, I'm going to hand it over to Pratik, who's going to get us started.
As consultants, we've had the opportunity to take a deep dive into the vast amounts of data collected and provided to us by Advanced Auto Parts. Now, this data set was incredibly rich, and it encompassed things ranging from population all the way to demographic variables. So to give a few examples, this includes things such as income, household compositions, age, and so on and so forth. So from the get-go, it became very clear to us that having a data set of this size meant that the opportunity to extract decisions was huge. But the challenge that we faced was how exactly do we leverage such a complex data set in order to make effective and accurate predictions as it relates to predicting new store performance. Our first step in the process was to ensure the integrity of our data. Now, this included addressing any inaccuracies, filling in any missing values, and essentially standardizing our data. And this was an important piece for us because it set a solid foundation for all subsequent analysis. Second, we moved into our regression analysis, and here we did a deep dive into the data in order to uncover any meaningful patterns and correlations. And by employing the use of statistical analysis, we then narrowed our focus down on the variables that explain store performance the best. However, something to note here is while we were able to get insights from this method, we did not gain the optimal predictive accuracy, which is why we pivoted into our third step of the process, which was a comparison of various machine learning techniques. And the purpose of this step was to look at the machine learning technique that had the best accuracy when it came to solving our problem. So with this in mind, we chose to build our neural network as it had the most promising results. And this was essentially an advanced predictive technique that used machine learning to analyze complex trends within our data to make a prediction about a future store of whether or not it would be above or below the median gross margin levels of all stores. And this was key for us because not only did it help us navigate through complexities, but it also helped us capitalize on opportunities with a high predictive accuracy. And then finally, we took it home with our economic analysis. Here we were able to illustrate the financial implications of our model, and we were able to do this by analyzing the potential cash flows received from the model should it be implemented. And by doing that, we painted a picture of the value this would bring to the organization. And now I'll hand it off to Bobby to take us into the solution.
Thanks, Pratik. So after considering a wide range of machine learning options, we decided to move forward with a neural network model as the optimal tool for our situation. So getting into some of the details on how the tool actually works, to start, the user will be prompted to enter in 5 different input variables. These variables were chosen automatically within our Python program, so they weigh the relationship and significance of all the variables on the target variable. And so the model works by taking these 5 input variables and then leading to a singular value of gross margin, for which we created a binary variable to determine whether or not the store would be projected as over or underperforming. This is determined by showing whether or not a store will be above or below the median gross margin level of past Advanced Auto stores. So now that we know how the tool works, we can get into some of the model performance and how well we were actually able to predict these new stores. So starting with the training data, in which we allocated 80% of the stores that we were given. This stage is important for helping the model become accustomed to the different patterns and trends that lead to specific outputs in the data. And we found the accuracy for this stage to be 77.5%. Then once the model has been trained, we can move on to the testing stage, where the remaining 20% of the store data was allocated. And we found that the accuracy for this stage was 73%. And this is the most important part of the analysis, as it shows how the model can react to new data being brought into the system. And so for a few key takeaways from this, we can say that this is a reliable tool for projecting store performance, as there's minimal drop off between the training and testing phases and accuracy. And also one more important thing to note is that sample size is an important factor in the model's learning capacity. So as more stores are introduced into the model, we can expect these accuracies to increase. Next, I'll pass it off to Jared for some return on investment analysis.
Thank you, Bobby. So to calculate return on investment, we performed a traditional discounted cash flow analysis, where we took sales, cost of goods sold, depreciation, amortization, SG&A expense, and capital expenditures to get the future free cash flows for both the above and below classified stores. We then discounted it back to the present value, and the difference between these two is what's seen as the opportunity cost of a correctly predicted store. While the actual figures have been hidden for confidentiality purposes, it's important to note that the difference between the two is a positive value, implicating a positive gain for Advance Auto over the next 5 years. Next, we wanted to see how our model would perform if it was implemented for all future new store openings, looking at historical 10K data. From this and a 2% sales growth rate, we're able to see that it is positive and increasing over the next couple years. And it's also important to note that certain discount rates, growth rates, and economic conditions are subject to change, and these figures are not set in stone. Now I'll pass it off to Gift to go over recommendations.
Thank you, Jared. For the final recommendations, we recommend to apply the subset of the stores that are going to be open in the future to our neural network model in order to select the location of the new stores and then track the performance of the stores and compare it to the baseline. If it outperforms the baseline, then our model can be implemented to the future store openings. And moving on to some next step possibly for our model. To increase the effectiveness of the models, we recommend to apply all of the available store data to our model and then also use the real-time stores reporting structure using the cloud database to make the data easier to be added to our model. And finally, continue to run and tune the model to ensure the optimal predictor variables. And next, I will pass back to Pratik for the final comments for this project.
Thank you, Gift. So we learned a lot the past 9 months working on the project, and we've summarized 3 main takeaways. First is to not be afraid to ask your sponsor any questions. We found that our sponsor came with a lot of experience and real-world problem-solving abilities, and that by proactively reaching out to them and asking them questions along the way, we were able to deliver a final, smooth, polished product. Second, the solution can change at any moment in time. This is a given with a project of this length, and the best way to tackle this is to have a positive attitude and being able to be flexible with whatever challenges that are thrown your way. And then finally, leading on the support of the CBA staff, whether it's a question about technical analysis, general recommendations, or even presentation tips, we found that they were there every step of the way. So we can't thank you guys enough for that.
Thank you all for listening to our presentation, and if there are any questions, we'd be happy to answer them. Thank you.
Let me just go ahead and start off with questions. I used to help you guys out with this one. So Roger Friesleben, good guy, really like it. Question I have for you is your last 3 bullets were very succinct, and I agree, asking customers questions is very important, because the truth of the matter, in the consulting world, they're not hiring you because they have all the answers. They're hiring you because they need to get answers from you. So it requires you to ask questions. My question to you is, in this process, you probably had a lot of different data that came at you. It seems to me in your presentation that that's the case. How long in the life cycle of your project did you finally get comfortable with that data? Was it all given to you at once, or did you have to ask for pieces of it as the project went along?
Well, we were given the chunk of the data up front. And we were given sales for DIY, pro, and then total sales per site ID. But then we wanted to pivot into gross margin because we thought it better valued a company's profitability as accounting for costs.
Right.
And so that was the only data that we had to add on to the initial data set.
So they had a pretty good idea of the scope of the project and the data they need.
They did,
Say
but
thank you.
Yeah, yes, so your inputs included 5 variables, and most of them seem to be heavily weighted toward demographics. Did you do any type of sensitivity analysis to see how the model would respond if you eliminated, say, the SKUs and the competitor analysis and just used demographics to predict store performance?
Yeah, so within our Python program, there's in the code, there's a way that it goes through all the variables and picks the combination of them that would end up with the highest accuracy. So I just went with that, really end up with the highest accuracy.
Okay, so would your gut tell you that if you just eliminated the competitor analysis and the SKUs and just focused on demographics, do you think that you would have gotten a pretty good result just based upon that information alone?
Yeah, probably would have been pretty strong, but maybe not as strong.
Okay, thank you.
I'm curious, did you take into consideration the impact of the store leadership and the staff and their effectiveness in the analysis?
that was a question was brought up with our sponsor meeting as well. And there was no way in the current system they have to quantify that. Our suggestion was to do a company survey, and to like rate leadership on a scale of 1 to 10, whatever number you want. And that would be a way to quantify it and include it in the model, but there was no current number for that.